So we've been talking the last couple of weeks in section 5.1, we're finding some numeric examples. So for example, sine equals 3/4. What does cosecant? What does tangent equal? Then we moved on to simplifying. And I kind of told you with simplifying, eventually we'll have a final end, how we know when we're done and what spot to do. That's what this is. So section 5.2 is verifying trig identities. And so like I keep saying, this is definitely difficult. So simplifying is really important to get good at this. And we've talked about a number of these different things, and I'm going to have you pause this. I want you to pause this video and copy all these down. Okay, here's the first thing. Transform the more complicated side of the equation into the form of the simplest side. So you pick the most complicated side. Start with there. You're not done until you get to the other side. So that's how you know where to stop. With the other simplifying problems, we weren't sure. Like, okay, am I done? Can I break this down? Am I, is there another way to keep on going with this? And that's what we had to question. This we know we're not done until we get to the other side. Now, one thing to mention is you pick one side, like I just said, and get to the other side. As you'll see some examples, you cannot add to both sides. You can't divide to both sides. You can't subtract. This is not a solving equation problem where I draw a line down from the equation and I add cosecant to both sides. You cannot do that. Pick one side, start from there, and you're not done until you get to the other side of the equal sign. Next, substitute one or more basic trig identities to simplify the expression. So that means if you see a sine squared plus a cosine squared, that equals 1. That means if you see a 1 plus tangent squared, that's equal to secant squared. That means if you see a tangent, that's sine over cosine, those things. Factor and multiply. If you can factor, if you see something in common, factor it out. That might work. Again, these are tough because there's not necessarily one way to do them. If you see parentheses, you can multiply, those type of things. Same thing, take a pause and copy these down as well. Multiply both the numerator and the denominator by the same trigonometric expression. This is mainly for combining two fractions. So with two fractions, we've done a lot of dividing and multiplying by fractions, but a reminder, you're going to have a lot more of these adding and subtracting. It has to have a common denominator for you to be able to do that. So that's where you have to multiply the top and bottom by one of the fractions by that. And so that kind of just goes along the lines of something you've done before, where, for example, if you had 1/2 and then you have over here, this is 3/4, let's say. That's not common. So we had to multiply both top and bottom here by 2. And then that way I would get a 2/4 plus, and then over here you get that 3/4. So now we have a common denominator. And like always, we write the denominator once, and then you add, in this case it says plus, so I add the numerator, so you get 5/4. It's going to be the same thing except with trig identities. And as we've been talking a lot about, get everything in terms of sines and cosines. That's kind of the bread and butter of what we've been working on lately. So, all right, here we go. So verify this. So again, take the more complicated side and we simplify it until we get to the less complicated side. So if I look at both of these, which side's more complicated? Hopefully you can agree that's this side there. So I'm going to break this side down. And I'm going to try the bread and butter here. I'm going to try to make sure that I have this down to sines and cosines. So if I see a sine or a cosine, rewrite it. So I see a cosine on the top, I'm going to rewrite it. On the bottom, I see a sine. I'm going to rewrite it. Next, if I see a secant or cosecant, I use my reciprocals. So 1 over sine or 1 over cosine. I don't have that here. Finally, tangent or cotangent. If I see those, I use my quotient identity. So tangent is sine over cosine. Cotangent is cosine over sine. Now, you've got cotangent squared. So cotangent is cosine over sine. So cotangent squared is cosine squared over sine squared. So we start by doing that. And I always like to kind of do this where I say, okay, well, that's over 1. Because what I'm looking for is a lot of times stuff cancels. So if it's on top and bottom, it cancels out. So I need to kind of simplify that a little bit. And so it looks like I forgot my square there. So I need to simplify this as far as I can go. So is there something on the top and bottom? Well, if you look, there's a sign here and there's a sign on the bottom. Now, this doesn't cancel completely because this has 1, this has 2. Remember, sine squared is really sine times sine, but I can take 1 away from each. So this one has 1, I take it away, it's gone. This one has 1, I take it away, I'm left with just 1 of them. And then that would leave me with that cosine is still on the top, divided by, I now have this cosine squared is going to stay there. So cosine squared over, now this is just a sine. We've talked about, okay, if I have a fraction divided by a fraction, that's always the top times the reciprocal of the bottom. So this top is cosine. Kind of a keep it, change it, flip it. So I keep the top. This division turns to multiplication, and then I flip this fraction. So this then will turn to sine of A over cosine squared of A. And I'm going to write this as over 1. So do we see something I can simplify? Can I cancel stuff out? Well, yes, I'm able to. Again, this is a partial cancellation. I have a cosine here and a cosine squared. I'm able to take 1 away. So I'll take 1 away from here. It's gone. I take 1 away from here. I'm left with just 1. So up top, I've got a sine of A. Over on the bottom, I'm just left with a cosine of A because I had one, I took it away. Now again, what am I trying to find? Remember how we talked about, you start with the more complicated side and you're not done until you get to the other side. I'm done when I get to tangent. So I'm still not done here. But we know quotient identity tells us that sine over cosine is tangent. So I know I'm done now. Then I verified it. I confirmed it. I broke it down until I got to the other side. Reminder, you cannot times both sides by sine. You can't divide both sides by tangent. You pick one side, work with that until you get to the other side. So this is your ending. This is the light at the end of the tunnel. You're not done until you get to the other side. And I verified that, and am I done? Don't be like the person that gets stuck and just says, oh, I got to equal to tangent when you know clearly you didn't. You're going to get stuck on these. That's okay. Just ask for help. Okay, verify. Cosine of A equals cotangent divided by cosecant. So same question. Which one's the more complicated side? Hopefully, again, we can agree that that would be this. So I'm going to break that down. That bread and butter, that one that we use so many times, get it down to the sines and the cosines. So cotangent. We talked about how cotangent, like I saw in the last example, that's cosine over sine. Cosecant. We use a reciprocal identity. So remember, sines and cosines, you rewrite them. Secant, cosecant, you use your reciprocals. That's 1 over sine. A reminder, looking ahead, I'm not done until I break this side down to be this side. So my final thing is I've got to get a cosine of A somehow. And I have to do it mathematically in a legal way. I can't just cancel stuff out because you think it cancels when it doesn't. So keep it, change it, flip it again. The top stays the same. Cosine of A over sine of A. Change division multiplication, and then I flip this fraction. 1 over sine is now sine over 1. Then, does something cancel? Well, sure. Just like before, I have a sign here and a sign on the bottom. That's the only way they cancel. Remember, they have to be on the top of the fraction and the bottom of the fraction with multiplication going on. I can't cancel if it's a plus or minus because you need a common denominator there. But I have a sign on top and a sign on the bottom. They're both just signed to the first, so they cancel out completely. That would leave me with the cosine of A over 1, which we know, of course, is just the cosine of A. And remember, we weren't done until we got to that cosine of A, which I did. So I'm going to put a little check mark to say I have now verified I got that cosine of A. So these take a while to get used to. If you've really been working hard on the simplifying, this shouldn't be much different. If you haven't, this probably looks a little confusing. So I might suggest going back and rewatching some of those videos just to guide you. Okay, verify, same thing. Which one is the more complicated side? Well, you can't get much simpler than 1, so it definitely can't be that. So I'm going to start on this side. And this has a couple of options. For example, I can break it down to sines and cosines and see what I have. Or I can do something else. I'm going to show you a different technique. This one, what do these both terms have in common? I have this term. So I've got this term, and then I've got this term. What do they both share? Well, they both share a cosine squared. So I can, guess what? Factor that out. I'm going to try that this time just to show you an example. So if I factor that out, remember, if you're factoring, you're taking cosine squared divided by cosine squared, which is 1. Plus, if I have tangent squared, if I've got a tangent squared, cosine squared, and I divide that, remember factoring is dividing. If I take that and divide it by a cosine squared, that cancels and just leaves me a tangent squared. So you can confirm that cosine squared times 1 is cosine squared, and if I do cosine squared times tangent squared, that's that. So a reminder when you do this, this is similar to if I had like an x squared plus y squared x squared. When you're factoring out that x squared, Remember, you're taking what you originally had and you're dividing by that number out front. So I'm dividing this by this number. And then over here, I would have this y squared x squared because that's what I have on top. And I divide that by this. So I'm technically speaking, when I factor, I'm dividing it. That cancels out and gives you 1. These cancels out and gives you that y squared. So that's why it works. And I know that's sometimes tough for people to see because you're doing it in a different way. But we are factoring like we've done before. And I'm just showing you this is one of the options. So here, this gives you cosine squared. I'm hoping you recognize this is an identity. This is a Pythagorean identity. 1 plus tangent squared. If you look at your Pythagorean identities, that's secant squared. Okay, so I simplify that. So that's just an identity. And again, looking back at that sheet that we talked about, that's super helpful. Okay, well, how can I keep on going? Well, guess what? Secant squared is the same thing. Remember, secant's 1 over cosine, so secant squared is 1 over cosine squared. Now I've got these fractions here. And again, I like to write this over 1. So can I cancel something? Well, in fact, I can. There's a cosine squared on the top. There's a cosine squared on the bottom. These cancel out completely. And guess what it leaves me? It just leaves me 1. Remember, I'm not done until I take the more complicated side and get to that. So I check that one off. There's another way that you could do this one. So there is another possibility that I could do this. So I'll kind of do this off to the side here just to show you. The other way is I could break it down in sines and cosines. So I could have cosine squared plus tangent squared. Tangent squared is really sine squared over cosine squared. And then this will stay cosine squared. Run out of room here. But if you look, that's supposed to be a cosine squared. That, technically speaking, is over 1. So what happens is I've got a cosine squared here that cancels out with a cosine squared here. That would then leave me with cosine squared plus sine squared. Now that should jump out at you because cosine squared plus sine squared equals 1 also. So that's another way to do it. So you could use that same, the same scenario that we have been using. That's perfectly fine. So that, again, not easy, I know. But that shows you that there's multiple ways to do some of these. All right, last one for this video. I've got a bunch of multiplications here. So what do? Well, I can do the distributive property, or I can FOIL if I want to. So that's what I'm going to do here. So secant times secant, that's secant squared. And again, I hope we can agree that this is the more complicated side. I forgot to mention that. But the other side's equal to 1, so I think we can agree upon that. So secant times secant, that's secant squared. Use back my blue. So that's secant squared. Then secant times negative tangent, that's negative tangent secant times secant. Then tangent times secant, that's a plus tangent secant. And then last one, tangent times a negative tangent, that's negative tangent squared. Okay. Now, if you look at some of these, there's something that you can do because a lot of time you do the distributive property, your middle terms are able to combine. Negative tangent secant, positive tangent secant. Well, guess what? Those completely cancel out. That's like a negative 3x and a plus 3x. So then that would leave me with a secant squared minus a tangent squared. Okay, rolling right along here. Okay, so that may not be, you may see that identity looks similar to that, and it does. And directly you could mess with that and get to that point. But I'm going to break this down in sines and cosines now. Secant squared, or secant's 1 over cosine, so secant squared is 1 over cosine squared. And then minus here, and then this is tangent squared. So tangent sine over cosine, so this is sine squared over cosine squared. Now, I'm not worrying about canceling out. There's a minus here, not multiplication. If it was multiplication, I'd worry about stuff canceling out. Not the case. Since you have a plus or a minus, this is where you need a common denominator. So the question is this denominator the exact same thing as this? The answer is yes. If it's not, you still have to keep on going. Now, because this is, I can write the denominator once, and it's cosine squared. Then at the top, 1 minus sine squared. 1 minus sine squared. So all I'm doing is saying, okay, these are the same denominator, so I read it once, and then 1 minus sine squared. This should look familiar to you. This right there should look very familiar to you because that's just cosine squared. So I get cosine squared over cosine squared. And think about that. If it's the same thing on top and bottom, that cancels out completely and leaves me with 1. And remember, our final goal was I have to get to 1. So I did. So I am finished. So again, these are not easy. But if you've simplified enough before, these aren't nearly that bad. But you're going to have to go back and start reviewing that. So pick the more complicated side, break it down and simplify it like we've been doing the last couple of weeks to get to the other side.